When the sun disappears below the horizon and the stars emerge, almost everyone, from the earliest humans to the present day, has gazed at the glittering lights above and drifted into thought. Among those who looked up at the star-filled dome of the sky, some, the first astronomers, tried to make sense of the celestial bodies that appeared each night but constantly shifted position. The daily rising and setting of the sun, the phases of the moon, and the seasonal motions of the stars came to be seen, especially among hunter-gatherer societies, as signs foretelling certain events. Because of this, people began making more detailed observations of the sky, recording the movements of these wandering lights more systematically and with greater precision. To aid them, they used large stones or carefully placed columns on the ground at spots with clear views of the heavens to mark significant celestial events. Structures like Stonehenge, with its pillars aligned to seasonal celestial motions, were not only gathering and ritual centers, but also primitive observatories. Yet those who wished to learn more about the heavens eventually found themselves limited by the capacity of the human eye. To overcome this, and to truly begin unlocking the mysteries of the cosmos, humanity would have to wait until the 1600s. Welcome aboard Spaceship Earth. In this video, we will explore the history and development of optical telescopes, those remarkable instruments invented in humanity's quest to understand the lights of the sky and which opened the doors of the universe to us. Ancient civilizations such as Mesopotamia, China, Egypt, and Greece observed the sky with serious scientific curiosity. They believed that changes in the heavens always had direct effects on Earth. When a star rose, floods might begin or storms might cease. Because of the sky's perceived importance, cultures such as the Babylonians systematically recorded celestial events for centuries, creating star catalogs. These records allowed them to calculate the periodic cycles of solar and lunar eclipses. In many kingdoms and empires, crucial decisions were made by consulting these catalogs. Ancient Greek philosophers, meanwhile, developed the first cosmological models to explain celestial motions. Aristotle, for example, argued that heavenly bodies moved in perfect circles. Yet all these efforts relied solely on naked-eye observation and rudimentary measuring tools. The instruments of the time were little more than the astronomer's eyes, a ruler, and perhaps a few fixed-angle markers. Still, curiosity about the sky and the practical uses of astronomy drove astonishing technological advances for their time. Among the most extraordinary was the Antikythera mechanism, a device so sophisticated it astonished modern scientists. Discovered in 1901 in a shipwreck off the island of Antikythera near Crete, this bronze mechanism dated back to the 2nd century BCE. It is believed to have been used to calculate the positions of planets, the phases of the moon, eclipses, and even the timing of the Olympic Games. Its intricate system of gears makes it the first known mechanical calculating device in history, and in essence, the first astronomical computer. Though based only on naked-eye observations, it was the first discovered device to convert such observations into systematic calculation, a striking example that the ancient Greeks sought not just to watch the heavens, but to understand, predict, and harness their rhythms. The Greeks also noticed that while most stars moved in fixed patterns, some did not. These lights traced irregular paths across the sky, at times appearing to move forward, then backward. Fascinated by these wandering lights, the Greeks called them planetes, meaning wanderers, a word that eventually gave rise to the English term planet. Mercury, Venus, Mars, Jupiter, and Saturn were counted among these wandering stars, and each was associated with divine powers. Their slow, complex, and unpredictable movements inspired both mythological interpretations and mathematical models. For the Greeks, the heavens were not just the realm of gods, creatures, and heroes, but also a mysterious domain where order was punctuated by irregularity. And among those mysteries, the wandering stars were the most captivating. In the 2nd century CE, Claudius Ptolemy proposed a geocentric model of the universe, placing Earth at the center. For the next 1,400 years, this model dominated astronomy. Astronomers tried to fit planetary motions into this framework, which was grounded more in belief than in observation, assuming the cosmos followed a sacred order rather than mathematical laws. But by the end of the Middle Ages, a wave of discoveries began to challenge this view. In the 16th century, the Polish scholar Nicolaus Copernicus published on the revolutions of the celestial spheres, proposing that Earth was not the center of the universe, but instead orbited the sun. This idea sparked not just an astronomical revolution, but also a theological and philosophical one. The fact that Copernicus was also a church canon magnified the impact of his theory. After him, observers such as Tycho Brahe carefully tracked the sky, recording the positions of thousands of stars with remarkable accuracy. His assistant, the German mathematician and astronomer Johannes Kepler, used these observations to formulate three laws of planetary motion. Planets orbit the sun in ellipses with the sun at one focus. A line connecting a planet and the sun sweeps out equal areas in equal times, and planets farther from the sun have longer orbital periods. These laws contradicted Aristotle's and Ptolemy's circular and perfect universe, but matched the real cosmos as revealed by precise measurements. Kepler's mathematical genius, grounded in careful observation, unveiled universal laws of motion, yet a new invention would soon transform how humanity looked at the sky, the optical telescope. In 1608, Dutch spectacle maker Hans Lippershey built a device that magnified distant objects using lenses, the first binoculars and telescopes. His simple lens system quickly spread, especially among sailors. Not long after, the Italian astronomer and physicist Galileo Galilei turned such a device toward the heavens. In 1609, building his own telescope, Galileo observed the craters of the moon, the four largest moons of Jupiter, sunspots, and the countless stars that make up the Milky Way. These discoveries were not just scientific, but ideological shocks. The universe was no longer a flawless, sacred realm, but a tangible, imperfect, and observable reality. Galileo's instrument was a refracting telescope, which used a lens to bend light. But refractors had limitations. Lenses produced color distortions, were difficult and costly to make in large sizes, and tended to warp under their own weight. To overcome these issues, Isaac Newton developed the reflecting telescope in 1668. His design used mirrors instead of lenses to focus light, eliminating chromatic aberration and enabling much larger apertures. Reflectors could collect more light, offering clearer and deeper views of faint stars and galaxies. Though mirrors required maintenance and their exposed tubes were prone to air currents, Newton's design quickly gained popularity and remains foundational in astronomy today. Over time, telescope technology improved and hybrid designs known as catadioptrics emerged, combining lenses and mirrors to balance advantages. Still, for professional research, reflecting telescopes became the standard. The 18th and 19th centuries were an age of craftsmanship and competition in telescope making. William Herschel built a massive 1.2-meter reflector in 1789, with which he discovered Uranus, its moons, and thousands of nebulae, galaxies, and star clusters. His sister Caroline Herschel also made important comet discoveries. Yet technological limits, such as poor reflectivity of metal mirrors, restricted further progress until glass mirrors and improved polishing techniques arrived in the late 19th century. This era culminated in the 1-meter refractor at Yerkes Observatory in 1897, the largest refracting telescope ever built. But soon after, reflectors again proved superior for modern astronomy. By the early 20th century, astronomers sought not only to see stars, but to measure their spectra, structures, and motions. The 2.5-meter Hooker telescope at Mount Wilson Observatory enabled Edwin Hubble to show that the universe is expanding, a cornerstone of the Big Bang theory. In 1948, the 5-meter Hale telescope at Palomar pushed the limits of engineering, using Pyrex glass and advanced cooling and polishing methods. It remained the world's largest optical telescope for decades, opening windows on galaxies, quasars, and the vast structure of the cosmos. As technology advanced, telescopes became smarter. Photography, long exposures, and later digital imaging allowed them to capture far more light than the human eye. Automated tracking systems enabled them to follow targets precisely. Astronomers began building telescopes in remote, high, and dry locations such as the Atacama Desert in Chile, where observatories like the Very Large Telescope, VLT, of the European Southern Observatory overcame much of Earth's atmospheric distortion with adaptive optics. Yet the atmosphere still limited observations. The solution was to launch telescopes into space. In the 1980s, NASA repurposed unused spy satellite technology to build the Hubble Space Telescope. Placed 550 kilometers above Earth, Hubble was not the first space telescope, but it became the most iconic. Its breathtaking images of nebulae, galaxies, and distant cosmic structures transformed both astronomy and public imagination, proving that the universe was larger, older, and richer than ever imagined. Whether atop mountains, in deserts, or orbiting above the Earth, optical telescopes have revealed how stars are born and die, how galaxies form, the existence of dark matter, and the age of the universe. What began as a simple arrangement of lenses has grown into massive observatories equipped with giant mirrors, supercomputers, and advanced instruments, all serving humanity's relentless curiosity about its place in the cosmos. From Galileo's first telescope to the grand observatories of the 20th century, the story of optical telescopes is the story of human curiosity, ingenuity, and determination to see the unseen. These instruments transform the night sky from a backdrop of twinkling lights into a laboratory where we seek answers to the deepest questions of origin and existence. The story of optical telescopes in the 21st century will be the subject of another video. Thank you for watching Spaceship Earth. If you found this video useful, please like and share it. You can support our channel by clicking the thanks button or joining as a member. Don't forget to subscribe so you don't miss our future videos on space and space technology. İstersen